Tecar therapy is a non-invasive electric current transmitted inside the human body by conduction that, when meeting resistance, produces heat through the Joule effect. Such heat has the function of accelerating metabolism, increasing local blood flow, increasing the elasticity of the stimulated biological tissues. Differently from all the other physical therapies, Tecar acts on the human body, through the manual action of the operator, who keeps the electrode in contact with the patient body. Therefore, we have no refraction and no reflection, differently from what happens with the other physical therapies. The device uses the capacitor physical principle. Two electrodes which concentrate the electric charges on their surface. The ions and molecules electrically charged inside the patient's body are attracted by the opposite polarity. Thanks to the polarity change generated by Tecar, the molecules vibrate with an alternate movement towards the electrodes accordingly to a frequency selected by the operator. The heat and electric stimulation produced in this way are endogenous, which means they originate inside the organism, and entail a deeper and longer action compared to other exogenous therapeutic currents. These results translate into biostimulating effect, acceleration of the biological tissue regeneration, anti-edema effect thanks to the improvement of tissue drainage, antalgic effect, reduction of the pain symptom in the stimulated area, biorelaxing effect, the warming of deep tissues reduces the muscle stiffness, and the antalgic contracture of the muscle groups near the damaged area. Therefore, Tecar is a useful tool that, in the therapist's hands, improves the result of every single treatment session, accelerates the tissue healing, and improves the relaxation of the patient. The stimulation of the patient can take place in two different modes: capacitive, resistive. In the capacitive mode, the electrodes are covered with a thin layer of an insulating material. The mode is used to concentrate the stimulation on low resistance tissues, characterized by a lower resistance to the passage of the electric current. Generally, these structures are more superficial, and fall within the category of soft tissues, like muscles. In the resistive mode, electrodes are completely conductive and the treatment is focused on high resistance tissues, characterized by higher resistance to the passage of current. For example, bones, connective tissues, aponeurosis, ligaments and tendons. Now let's see an example of capacitive treatment and resistive treatment being performed. In this example, we'll make a capacitive treatment on the patient's forearm. Thanks to the special electrode, we'll focus the charges on the surface and we'll be able to see how the temperature will increase in the area of the handpiece. In the resistive treatment, instead, charges will focus more or less halfway between the two electrodes and the patient will feel the heat in the core of the limb.